Hello everyone, today we're going to look at usaco-training prime palindromes. In this problem, we're given two numbers A and B, and we're supposed to find the number of palindromes that are prime, and they are within the range A to B. And it's inclusive, which means that both A and B are considered to be in the range. Okay, so for this example, we're given A equals 5 and B equals 500. And then here is the answers. Okay, so 5 is the palindrome. Since a palindrome is a number that reads the same forwards and backwards, 5 is 1 since it reads forwards as backwards. And so it's like 313, and all these are also primes. Okay, so let's write. So as this case, we're given A equals 5 and B equals 500. So one solution would just be looping through each of the numbers from A to B. So we could loop through from A to B, and then we could check if that specific number is both a palindrome and a prime. So if it is, we can just print it out. But then, since both A and B is in the range of 10 to the 9th power, this wouldn't work, since this would take too long. So then, notice that a palindrome, since a palindrome reads the same forwards as backwards, since it reads the same forwards as backwards, we can actually just generate the palindromes instead, because instead of generating 10 to the 9th, at most 10 to the 9th number of numbers, we can just generate basically the square root of this, because we're basically just generating the first, let's just say if it's 10 to the 9th, we generate the first 5 digits, and then the rest we know how to, since a palindrome means the same forwards as backwards. And then we just check if this is prime. And what I mean is that, for example, if you want to generate a 5-digit number, notice that has to be like X, Y, Z, Y, X. So then we loop through all possible X, Y, and Z. So then this can be from 1 to 9. This can be from 0 to 9. And this can be from 0 to 9. And since this takes only 10 to 3, this would work. And we only need to generate half the digits. Another example is, let's just say we're generating a 9-digit number. A 9-digit number. Okay, so it has to be X, or actually let's use A. So it has to be A, B, C, D, E, D, C, B, A. And we only have to generate these numbers. Okay, so that's basically it, and here we go. Okay, so let's include okay. So we have our A and B. So we're reading from P prime. Okay, so we need to read A and B. Okay, so now we need to generate our numbers. So we can actually write them out separately. Okay, so we can have a function where we can actually just write it out here. So here we need to first do our 1-digit numbers. And this we can do so we only have one variable, so if for I, and I'm actually just going to use macros, since it'll make this faster. AX. Okay. Okay, so now I just need to do, so for 1-digit numbers, it can be from 1 to 9. So for I, 1, 9. Okay, so basically you know that your prime or your number is I. Okay, so basically so we need to make a check function to make sure like this is both a prime and it is also in the range of A to B. So we can go check, let's call this check. So we're given a number. Okay. Okay, so first it has to be in the range of in between A and B. So basically if number is less than A or the number is larger than B, then you can return false. So now we need to check if it's a prime. Okay, so to do that, we can actually check it in log n. I mean square root of n. So we can do this. Okay, so it'll be 4. We can do 4, I, 1. Let's call, or we can actually just make a, so for I equals 1, I times I has to be, or I has to be, I times I has to be less than or equal to num. Okay, so if num mod, or if a mod I is equal to 0, then it means that it has a divisor, then you can return true. True. Else, then you can return false. Whoops, return. Okay. So now basically if check num, then you can basically append this to your answer. So let's call this a vector of integers, and you can answer the push back I. And notice that basically since the last digit of a prime, or basically we can phrase it like this: a prime like number always has to end in a odd number except for 2, so we can actually just use that to like speed up the cases. So we can also make another one. So basically let's call this PRI. So we can call this A. So it will be A equals 1. A has to be less than or equal to 9, and then you would just increment this by 2. Or let's actually call this odd. So now over here we can just do odd of I. So we basically only generate the odd like integers of I. Let's see. Okay, let's define. Oops. Okay. So now we need our 2-digit number. Okay, so basically we have basically odd. So our first digit is I. So we have our num equal to I times 10 plus I. And then, so basically we need to if check num, then we can push it back as well. Yeah, this should actually be num. Okay, so now we need our 3-digit numbers. Okay, so this is our first digit, so it would be I times 100. So now we also need our j times 10. So we can, and j can be in the range from it can be in the range from 0 to 9. So we can do 4j 0 9. Okay, so that is our 3-digit numbers. 4-digit numbers. Okay. So the format would be same as the 3-digit numbers, but then this would be 1,000 plus j times 100. Okay, so now we need our 5-digit. Okay, so we have our odd, and then we also need our k. Whoops. K09. And here we go. Whoops, this should say the same, and we need to add our k, so it'll be k times 100. Okay, so we have our 6-digit. Okay, so this would be, the form would be similar. But here we would also add k times 1000. Okay, so we have our 7-digit numbers. So this should, we should have, let's call this L09. We can do this as well. Okay, now we have our 8-digit numbers. Okay, so our 8-digit number would be similar to our 7-digit numbers. The only difference was that it would be having one more L. Okay, for our last one, we have our 9-digit numbers. Okay, so 9, and then let's call this M. Then we would add another 1 as well. M times 1, 1, 2, 3, 4. Okay. So now after this, we just need to basically we need to sort our answer. Whoops. Answer begin, answer end. Okay, so then we just need to print out our answers. So basically for each answer, we need to just, actually it's F out, so F out A and line. Okay, so let's get our input. For the sample, we have 5 and 500. So we have, this is the usaco-training, and this is prime palindromes. Okay, so let me just run this. Okay, so there's an error. Let's see what it says. F-stream. P prime.in. Okay, so the argument types are constant char. Yeah, stdin. Yeah, so it looks like maybe we can look at this F-stream thing. Oh, whoops. Looks like I did the F-stream thing incorrectly. We actually don't need this. Yeah. Okay, let me run this again. Okay, it's compiling. Okay. Finish running. Over here, we see that these are all correct. Wait, actually 393. 393 isn't a prime. So let's, because it's it's divisible by 3. Okay, so if must 3s. Oh yeah, so we actually did this the opposite. We actually have to do return false. And over here, 1 shouldn't be included since, you know, 1, since if you have 1, since every number is divisible by 1. So basically this means that if it is divisible by a number, then you have to return false. Okay, so let's run this again. Okay, let's check this. Okay, so it looks like that is right. I'm just going to submit it. Okay, so here's my ID. This problem is P prime, and my language is C++11. Okay, so here we go. Okay, usaco-training. This is prime palindromes. Okay, here we go. Okay, so it looks like that is right. Okay, so if you have any questions, feel free to leave them in the comment section below. Bye.